All right, good afternoon, everyone. So this video is for those of you in class on Friday, or for those of you who may have missed class on Thursday. If you're in class on Friday, then obviously I'm not here. So this is kind of your pre-recorded lesson and me just kind of walking you through what it is you need to do in Schoology, what your assignments are, how to do those. And any questions that you may have, I will address those when I return next week. So I'm going to go ahead and shut my camera off, and I'm going to screen share with you guys our Schoology page. All right. So here we are. I am sharing with you fourth period Schoology page. Of course, this is the same alignment that you should see for sixth period. So first thing you will do in class is you will, of course, complete the bell ringer here. And we'll talk a little bit about the bell ringer when I come back next week. Once you have completed your bell ringer, you will then move on to the student pace Nearpod mixtures. This is going to go through mixtures, review mixtures. There's going to be some sketches you need to do, some videos you need to watch. So make sure you go through those and you complete those. The next assignment for your class is to go through the solubility lab. So I'm going to show you what that looks like. So I'm going to open it here. And there are two things that you should see. One, there is the link to the PhET lab. And second, there is a lab data sheet. Okay, so when you open the sheet, the lab sheet, you're going to be able to type in it. This lab sheet has instructions for you. So it says, sugar and salt solutions, exploring common substances using the PhET simulation. So it tells you, even the link, even though I've already included it, it's there. You can scroll down and it says, in this experiment, you will explore the behavior of sugar and salt in water and attempt to classify these substances into categories. As you scroll down, it tells you exactly what to do. Open the sugar and salt solution simulation. You're going to spend some time exploring it, okay, playing around with it, changing the settings, looking at it, observing it. Then you will go through and you will complete the activities, okay? So your goal is to make the light bulb glow. And as you play with the lab, you should pick up on what it is that you had to do to make that happen, okay? So that's the lab document that you're going to submit. This needs to be submitted for a grade before you leave school on Friday. Or for those of you on virtual setting, submit it to me on Friday. Now, when you go back to solubility activity, here is the PhET lab. It's going to open up. Remember, some of you, excuse me, wrong document. Here's the link. Open the link for you. You may have to check your settings on your flash settings, but it should run for you. Sometimes it takes a minute. Okay, there it goes. So just be patient if it's running a little slow. Sometimes it takes a minute to open up. Okay, so this is what the lab's going to look like. So at the top, you will see macro or micro. This is where you change the setting based off what the lab is asking you to do. You can increase water, you can decrease water, you can evaporate water, you can add salt by shaking it. You can add sugar by shaking it. Okay, so you're going to go through the lab, the macro setting. You can also go to the micro setting, which changes things up a little bit. Okay, and you're basically going to play around with it. See what kind of observations you can make. How does this relate to solutions is what I want you to think about. So if you go back to the macro setting here, this little thing here is what represents conductivity. And so you can essentially put it in the water to take a measurement. If you need to reset, you go down and hit reset. Everything goes back to normal. The water will go back to the same level. So let's say you let a bunch of water out. You want to reset. You hit reset all and everything goes back to the initial setting. Okay, so again, your job is to play around with this. You can go to the macro setting, the micro setting, or even the water setting, which kind of zooms in on the particles. So you're zooming in on water particles and salt and sugar, and you can make observations and look at how they behave. But you're going to work through this lab, okay? And you will answer the questions and submit that for a grade through Google Docs. Okay, so this is your lab activity. So now I'm going to stop sharing this. Again, your job as the student is to work through this and manipulate it. Make your observations, complete your lab document that goes along with it. So I'm going to stop sharing this screen. And now I'm going to go back in to Schoology page. Okay. So again, back to our folder, Friday, October 23rd. So you should have done your bell ringer, student pace Nearpod, and your solubility lab activity. The last thing that I'm going to do is show you this mixtures and solutions PowerPoint. Okay, this particular PowerPoint right here introduces mixtures and solutions, and I am going to provide you with some questions that go along with this. So you're going to click on it. It's going to open up. And you will be able to scroll through and look at those. Okay, my screen's freezing up right now, but yours shouldn't do that, okay? So it talks about solutions, you have some key terms, and there's a document that's gonna go along with this, and you will fill in some questions about solutions. Okay, so I'm gonna stop sharing for just a minute to see if this will kind of fix my screen issue. All right, so let's try this again. So here we are back with Schoology. Okay, so once you have viewed the mixtures solutions PowerPoint, so that's listed right here, it says mixtures solutions PowerPoint, you're going to open up the solutions worksheet. And again, this will lead you to a solutions practice sheet, just a way for you to kind of flex your knowledge with what we've learned about. So you're going to put your name in here and you're going to fill in the information. Okay, so you're going to make sure that you match the best term and definition here based on the descriptions. You have 3 short answer responses, and then at the end, you're going to be filling in some blanks. Okay, so you will actually type on this document, and again, you are going to submit it for a grade. So I do want to go through the Schoology PowerPoint with you guys, excuse me, not Schoology, but that's embedded in Schoology. So I'm going to share that with you really quickly and talk a little bit about that. Give me just a minute to get my settings right today. Okay, so now everyone should see the mixtures and solutions PowerPoint. So a solution is an example of a homogeneous mixture. We have talked about this. We've already looked at this information, but we're kind of going to look at them a little bit more closely. So once you get to your lab, you will observe the difference between sugar water and salt water. Okay, but a solution is in fact an example of a homogeneous mixture. There are 2 terms, soluble and insoluble, that are important when considering mixtures, specifically solutions. Soluble means something will dissolve, and insoluble means that it will not. So, sugar, soluble, salt, soluble, baking soda, soluble. Pennies, rocks, pebbles are insoluble because they do not dissolve in water. There are 2 components to every solution. The first is a solute, and this is the substance being dissolved. So in the examples that you will be looking at in your lab, the solutes will be salt and sugar. Solvents are whatever substance does the dissolving. So for example, in your lab, that will be water. Okay, the solvent is typically present in higher volumes than compared to the solute. Some common examples: chocolate milk. Well, what have you done? You've mixed milk and chocolate syrup together. Kool-Aid, powdered drink mixed with water. And then, of course, there's also those yucky alcohol tabs that I personally don't like to drink, but you're making a solution. Water is considered a universal solvent. If you think about it, almost everything you do in terms of cooking, dissolving, washing clothes, all of those things, you are using water to do that. Water is the universal solvent because it is a polar molecule. We're going to talk more about this later, but there's a term that you should, or a phrase you should remember, and the phrase is like dissolves like. What does that mean? Well, that means that water is polar and it will dissolve other polar molecules. So salt, for example, is somewhat polar and will dissolve easily in water. Oil, however, is not polar. Oil is considered to be nonpolar, and so that's why oil, even though you shake it and shake it and shake it, it eventually settles out of water. You can see that in the visual here. What do I mean by polar? Well, because of the way hydrogen and oxygen bond, it causes water to have a slightly positive and slightly negative charge. So in this example here, the oxygen is the red atom and hydrogens are the two little white ones. And so this results in a slightly negative and a slightly positive charge. We're going to learn that salts formed through ionic bonding also have a positive and negative charge. This is why salts dissolve really, really well in water. The term aqueous refers to water as well. So a solution in which water is the solvent is termed an aqueous solution. Okay, we're going to skip that part. A couple other terms: saturated versus unsaturated. If you have a beaker of water and I ask you to put sugar in it, initially it would dissolve. But if you continue to add sugar and more sugar and more sugar and more sugar and more sugar, eventually the water would reach a level of saturation, which means that no more sugar will dissolve. So you have reached the maximum threshold. We will also talk a little bit about the fact that temperature and pressure can impact solubility as well. Unsaturated means that there is not a lot of stuff dissolved, and so you can add more to it. Okay, so unsaturated means there's not a whole lot of particles into it, so you have more room to continue to dissolve other substances. Miscible refers to liquids that are soluble in each other. So water and vinegar mix really easily. You can also mix things like bleach and water. Those are miscible. Acetone in water. Acetone is basically fingernail polish remover. So you can dilute concentrated acetone in water, and that's basically what you get when you buy fingernail polish remover. So these are all examples of miscible liquids, meaning that two liquids can dissolve in another and it leads to the formation of a solution, which of course is still a type of mixture because they are not chemically bound. Immiscible refers to oil and water or oil and vinegar, okay? Anything that doesn't dissolve easily or liquids that do not dissolve easily into another liquid is called immiscible, meaning they do not mix. So examples: oil and water, oil and vinegar, those would be considered immiscible because they separate and do not dissolve. All right, so we're going to pause here and I'm going to stop sharing my screen. We'll move through some of the material included in this assignment later. So I'm going to stop sharing. Okay, I'll come back to you guys here. So again, your expectations for the 23rd are to complete your bell ringer, complete the student pace Nearpod. You need to complete your lab activity and submit that through Google Docs. You will then go back and review the PowerPoint that is embedded in Schoology and use that to answer your questions about solubility. Okay, so those are your assignments for Friday, October 23rd, for both in class and online. Okay, so you guys have a fabulous day, have a fabulous weekend, and I will see you in class next week.